Good afternoon. My name is Peter, and today I will be starting the first of a two-part math activity for Cognition of Davy. The first part today, we are going to build, construct, and fly some paper rockets. And then in the second part, next Monday, we're going to go ahead and start to pick some landmarks out of the data that we collected. So for today, you're going to need a couple of materials. Most of them are probably just lying around at home. There are a couple of papers you may need, and those are available for download in the comments section. So you're going to need one of these, a soda straw rocket template. These materials were originally developed by NASA and JPL. Credit to them for doing that. Additionally, you can also download a little data collection chart. You're also going to need tape, a measuring tape, a scissors, and a straw. A word about straws. There are actually a lot of different types of straws. The good news is you can do this activity with almost any kind of straw. However, like many things, some straws are better than others. Probably one of the very best straws that you could have would be one of the very fancy new stainless steel ones if you're using the same straw over and over. Kudos to you if you're doing that. I don't happen to have that. Another great straw would be a thick or a wide diameter milkshake straw. I was unable to find that in my local mart. However, I did find these paper craft straws. That will work just fine. You're going to need to take your soda straw template and you're going to need to cut out the two rocket fin pieces as well as the rectangle, which is going to be our fuselage. Now, it is going to take you a few minutes to cut them out. I know that it did for me. Sometimes, as a dude, I kind of think that some things could be done really, really fast and it doesn't really matter if they're done well or not, but I'd like to encourage you that this is not one of those things. Not only are we doing math, but we're also building rockets, and both of those require precision, as does mathematics. So if it takes you a couple of extra minutes to really cut out these parts well, take that couple of extra minutes to do it well. You're going to get those minutes back in the joy of seeing your rocket fly further than your brother or sister's rocket. Take a few minutes now, cut out your parts. By now you've cut out your pieces and you've taken great care to do it to the very best of your particular ability. So next we're going to begin to construct our rocket. We're going to need some tape. You might start by taking a couple of pieces of tape and perhaps staging them at the end of your table. I'm going to take my straw and I'm going to wrap my paper fuselage around it. And full admission, this is maybe just a little bit fussy depending on the diameter of your straw. If you have a big straw, this is probably a bit easier to do than the pretty skinny paper craft straw that I have, but I will persevere. So I've got it wrapped around my straw at this point, and I'm glad that I staged some pieces of tape. I'm going to go ahead and tape the two seams, or the seam where the one paper meets the other. All right, I have successfully taped my paper around the straw. Now you notice just there that when I tipped the straw, the rocket actually began to slide, and it slides fairly freely. That is a really good thing. Sometimes, again as a dude, I think that the tighter I could possibly wrap something, the better. This is not one of these cases. You do actually want the rocket to slide back and forth relatively easy on the straw. If it doesn't slide back and forth, you need to stop and fix something because you're going to be blowing through the end of the straw, creating air pressure inside of your rocket, and that's what's going to cause it to fly off the end of your straw and hopefully create a good flight. If, for whatever reason, if this is too tight, you're going to lose a lot of that energy and your rocket won't go as far, and we don't want that. Or if you miss a spot and your seam is not entirely taped, you may be leaking air out of the side, and again, your rocket is not going to go quite as far. So if you need to fix those issues, definitely do so. I don't have those issues at the moment. So I'm going to go to my next step, which is taking one end, and it doesn't matter which end, and folding it over to make a little nose cone for myself. There, I just folded it like that. Not complicated. And I'll put a little piece of tape over the end. There, I've done that. And finally, the last thing I'm going to need to do is to tape my fin pieces onto the bottom of the rocket opposite the nose cone. This also can be just a little bit fussy, but I will be patient and we'll get through it. I'm going to tape it on as straight as I can because I know that straight fins are going to create a better, more stable flight for my rocket, and therefore your rocket's going to go further. All right, so I've taped my fins on. This is what it looks like on one side, and that's what it looks like on the other. Now currently, I have not taped the back of them on, so they're still kind of floppy, and I am going to need to remedy that situation. So for this, my tape here is fairly thick, so I'm actually going to take it and very carefully with my scissors cut it lengthwise so that I have a longer, skinnier piece of tape. And I probably only need one of those. And then I'm going to carefully wrap the other end, hoping to get those end pieces taped on. There we are. Looks like I'm successful. Now my fins are still laying fairly flat, and these fins are better than no fins, but not nearly as good if you take them and spread them out a little bit. So I'm going to take my fins and fold them up. And the fins on the other side. So the bottom of our rocket now looks roughly like this, like the shape of an X. We've created our rocket, and next it is time to actually fly it. Now, as I mentioned before, I am a dude, and I have a brother, and if he was here, I would be so tempted to take this rocket and just shoot it straight into his face. But that's not what we're going to do, because this is a math activity. Now, it may be possible that later, when you're all done with your rocket, if your parents or guardians have given you express permission to do so, you perhaps could shoot paper rockets at your brothers or sisters, but nobody with paws, because that's not fair, they can't shoot back. So next, you're going to need to find a location where you can go ahead and shoot your rocket. Now, probably you've already shot it once at this point if you're anything like me. So you may have already noticed that if you built it reasonably well, it actually goes a pretty fair distance. So you might find the living room or the hallway or even the garage, some uninterrupted area of space where you can go ahead and shoot this thing as far as it will go. Also, you might want to pick up some kind of measuring device for the next step, because we are, of course, going to collect some data. This is a math activity. So take a moment and relocate yourself to an appropriate rocket shooting area. And we're back. So by now you have relocated yourself to an appropriate rocket shooting gallery. So I'm upstairs in my wife's office, and I've got probably 20 good feet of carpet ahead of me. Now we're going to sit down and look at the floor for a moment here. I've taken an extra straw I happen to have, and I've set it on the floor here as my start line or my zero line. And this is really important. If you're going to collect accurate data, you have to start from the same place every time. Otherwise, it's not going to be very good. So I'm going to go ahead and do all my rocket shooting from here. I'm just going to stand here and use the pressure in my lungs, and I'm going to try to blow about the same pressure each time. So I'm going to go ahead and shoot two of the rockets that I have constructed and we'll see how far they go. All right, that's respectable. And for the second one, I'll angle and try to shoot a little bit more up. Maybe I'll get some more distance out of that. Maybe not. It is an experiment after all. Oh, that did go further, and it even scraped the ceiling and very nearly hit my wife's foot. Although, as you can see, when it did bounce, they did end up pretty close to each other. That's probably then the way I'm going to measure them. Now, of course, a standard way to measure how far they went would be to use a tape measure. Here in the United States, we use the customary system most of the time. Inches and feet, particularly feet, would be excellent for this, because most units of measurement are just arbitrary distances human beings decided upon, and then we agreed that that's what we would call it. This is, of course, where the term foot comes from. It was the actual length of a former king of England's foot. He decided that was going to be the standard, so he standardized a foot. That's all it is. So if you don't have any of these tools, you can still use your own foot, and you can simply pace off how many footsteps it was from your start line, which for me is a straw, to my actual rockets. So I will do that now. 1, 2, 3, 4. So for me, that is just about 14 for both rockets. Now, that's not the same as a standard measured foot, but as long as I have consistency I'm using in my units, that will be fine. So now I'm going to record 14 for both of my first rockets, and then I'm going to shoot each rocket 9 more times for a total of 10 launches with each rocket in order to collect my data. If you only made one rocket, that's just fine. You can go ahead and just shoot the one rocket. We can still do some real math next week on Monday just from that data. Go ahead now and shoot your rocket, collect your data, write your numbers neatly so you can read them, because they are your numbers. It doesn't do you any good next week if you can't reread your own handwriting. And in a moment, I'll show you my own data collection sheet. All right, so by now you have shot your rocket or rockets at least 10 times, and you have collected your data. Now in my data, I did choose to just pace off each rocket distance, and I also chose to round off to the nearest whole unit, which in this case would be the length of my foot. Now, you don't have to do that. If you want to take this and make it much more challenging, you could use inches. And then you're going to have much bigger numbers to work with come back next week. Or, of course, you could use fractions, creating mixed numbers for each one of yours if you, again, want to kind of turn up the heat on the difficulty of the computation that we may be doing next week. But for now, this is what you should have, and I'm looking forward to seeing you next week so we can start to process our data into some real landmarks. Bye for now.